Hello everyone, this is Shruti Saxena Das, and in today's lecture we are going to discuss about introduction to linked list. So first of all we'll discuss what is the need of linked list, and then we'll move on to the concept of linked list and types of linked list. So first we'll start with the need of linked list. So what is the need? Normally we use arrays to store elements. If you want to store homogeneous type of elements, then most of the time we use array. But what are the main limitations of arrays? The first limitation of array, in the need we'll discuss why we can't use array for everything. So the first limitation of array is the size of array you need to mention at compile time. So size of an array is defined at compile time. So when you are writing your program, at that time only you need to specify what will be the size of the array, and whatever size you are specifying, that becomes fixed. So in case you are giving size as 5 and you want to insert more number of elements than 5, like suppose you want to insert 10 elements, then you can't insert, because the size which you have specified, that is 5, so it can accommodate only 5 elements. Now if in case you want to store only 2 elements and you have mentioned your size as 5, in that case also you are wasting the space. Okay, so that is the first limitation of array, that you have to specify the size at compile time only. Secondly, in case you want to perform insertion or deletion operation in case of array, then these operations are very time consuming. So insertion and deletion, these procedures or these operations, if you want to perform on an array, then these takes so much of time. Okay, because in case you want to insert any element in an array, suppose there is one array, this is your array, and the size of the array is 5. Index will be from 0 to 4. Now suppose you are having like suppose you are having 30, 40, 50. Now these are the elements and you deleted 20. In case you deleted 20, in that case this space is free. Now when you'll normally see, for performing any operation in case of array, you need loops. Now after deleting this array, you need to shift all these elements by 1. Why? Because you'll use loop for traversing. If you, in case you want to print all the elements, then after deletion of 20, it should print 20, 10, 30, 40 and 50. So to do this, you need to shift all these elements by 1. Okay, it is not going to give any space over here. So you need to shift all these elements to by one place. Similarly, if you want to insert any element, suppose there is one more space, suppose the array size is 6 and I want to insert 35 between 30 and 40. So I want to insert 35 over here. So I need to create a cell or a space for inserting 35 in between 30 and 40. So for that also I need to shift 50 to this place, 40 to this place. After that only here space will be created and I'll be able to insert 35. Okay, so these are the problems in case of array. So in case you want to perform insertion or deletion, because the size is fixed, and if you want to perform insertion or deletion, you need to shift elements and that takes time. So these operations are time consuming. Then the third thing is that array requires contiguous memory allocation. Now what is this contiguous memory allocation? Contiguous memory allocation means one after other elements will be stored in contiguous memory locations. That means if this first element is at 1000 and suppose you are using an integer array, and integer takes 4 bytes, so this will be stored at 104. Okay, so this element is going to take 4 bytes, and after that next location will be after 4 bytes. Then this 30 will be stored at 1008. So like that it is going to store all the elements one after other in the memory. So these are the main limitations of array. Now to deal with these problems of array, there is a concept of linked list in which all these limitations can be removed. So that is the basic need of linked list. Now we'll discuss what exactly are the properties for your linked list. So we'll discuss that. The first properties of linked list. The first property is that here we do not require to store elements in contiguous memory location. We do not require. Okay, so the first thing is there is no need to store elements at contiguous, because we are going to use the concept of pointers over here. Okay, memory locations. Secondly, here elements can be inserted and deleted at runtime. We can insert as many elements as we want. Depends on your memory of the system. Whatever system you are using, if memory is available, then obviously you can store as many elements as you want. So insertion and deletion of elements can be done at runtime by the use of pointers. Through pointers we can perform insertion and deletion at runtime. So at the time of execution you can insert elements or delete elements. So that's why we call linked list as dynamic data structure. So this linked list is also known as dynamic. Known as means it is dynamic data structure. Okay, as we can insert memory, as we can insert elements at runtime, that means that if we need element, then only we are going to create space for that. Okay, like in case of array, we were initializing or we were declaring the array with some specified size. So at the compile time itself, we were fixing the memory for that particular array. But here in case of linked list, we'll insert as per need or delete as per need. So that's why we can call that linked list promote efficient memory utilization. So here memory utilization is more efficient because here we do not require to pre-allocate memory to insert elements. Okay, so if you don't need elements, we can deallocate the memory. If you need elements, you can create memory space for those elements. And in insertion and deletion, that's why are easier as compared to array. So insertion and deletion are easy and efficient. Okay, so these are the properties, or you can say that these are the basic concept. This is the basic concept of linked list. Now, how do we represent a linked list? Linked list. Now we'll come to the definition part of the linked list. Linked list is the collection of nodes. Okay, collection of nodes where each node comprises of two fields. Each node comprises of two fields. The first field is the data field. The second field is the address field. So the first field data field, that is going to store whatever data you want to insert, and this address field is going to store the address of the next node. So linked list is going to contain elements in the form of nodes where each node will be represented in this form. The first first part of this node will store data. The second part of this node will store address. Now suppose you want to store 10, 20, 30. Okay, so how a linked list will be created? It will be like this. The first node is containing 10. Okay, the next field or the address field of this particular node, it will be a pointer. Pointer stores the address. Pointer is a variable which stores the address of any other variable. So here this particular field is going to store address of the next element. Okay, 20. Now this 20, again it will be a node. Data field will contain 20 and the next field is going to contain the address of the next node. Now next node contains 30, and here as this one is the last node, that's why we'll store null as in the address field, because here this node which is containing 30 as the data field, it is not having any more element after this. Okay, so this particular node is not pointing to any other node, that's why we'll write null over here. So these are the three nodes, and suppose this 20, this particular node is stored at 1000 memory location. So that means the next field of this node, which is having 10 as the data, will contain 1000 over here. Okay, pointer to memory location 1000, and at 1000 you are having 20, and suppose this particular element is at 2000, so here we'll be having 2000 as address. So this 20, this node which is containing 20 in the data field, will be having address as 2000. So this particular field will be a pointer which will point to memory location 2000 where 30 will be stored. So it will be like this. Okay, you can see that this is I've shown that this will be at 1000, this will be at 2000. These are this is just an example. Okay, suppose this one is stored at 1000 and this one is at 2000, then you can see that these are not contiguous memory locations. Okay, these are completely different. Okay, these are not contiguous. So linked list, in linked list there is no need to store elements at contiguous memory location, because we are using the concept of pointer. So here the address will be stored in the next field or the address field. Okay, so this is the basic concept of linked list. What is the need and how do we represent? Now we'll discuss that how to create a structure for this linked list. Like normally when you take suppose I have to store an integer value, suppose 10. If I want to store 10, then in that case if I want to store 10, then normally what do I do? To store this particular element or this particular value, I take integer x equals to 10. So like this, I can store this number 10 because this is an integer. I can take integer data type and one variable, and I can declare that particular variable with integer data type, and I can initialize it with 10. But now I have to create something like this, where here I have to store some data. Let's suppose I want to store some integer data, and in the second field I want to store a pointer, okay, which will store the address of the next node. Okay, so I need to create a structure. Now you can see that here the first field is of integer data type, the second field is of pointer data type. Okay, now both the data types are different, so you must be aware about structures. A structure is a data type in which you can store different type of elements. Like array is a collection of homogeneous data type elements. Structure can store heterogeneous data elements. Now here you can see the first element is integer, the second element is pointer. Both the elements are of different data types. So to store this, we'll use a structure. Now how to create a structure for a node? See, I'll write struct keyword. To create a structure, we need to use struct keyword. So I'll write struct. I'll give some name. So as I'm going to use node, so I'll write node. I'll start writing structure. The first field is integer, so I'll write int. Variable, I'll use data only, int data. The second field is pointer field. Okay, suppose I'll give the name to this field as next. Now this next is a pointer, so I'll place this pointer symbol along with this next. Now what will be the data type of this next variable? The data type of this first field is integer, because I'm going to store integer value in this particular field. Now in this field I'm going to store address. Address of what? Address of any other node, okay, which will be again of the same type. Same type means it must be containing first integer value and second next value. Okay, so here the data type which we are going to use will be struct node. Okay, so this will be the structure for our node. Okay, this will be the structure. Now one more thing here I'll discuss, that in because we have to use this struct node again and again, whenever you'll give memory allocation to a particular node, we have to use malloc for that. And whenever you'll use malloc or you'll create any new node, you need to create a pointer of struct node type. Okay, so for that we'll use typedef. Typedef is used to create an alternative name for any data type. So here for a struct node, I'll give a name as n. Okay, so wherever I have to use struct node, I can use n. Instead of struct node, this is the type over here, I'm giving an alternative name n. This is not mandatory, but as we are going to use struct node again and again in our programming, so that's why I'm giving an alternative name which is simple. So I'm giving n for this. Okay, now we'll discuss about the types of linked list. So the first type of linked list is single linked list. In case of single linked list, the two nodes are linked with each other in linear manner. That means whatever we discuss now, so it will be like this. Okay, here it will be null. Suppose there are 3 nodes only, so it will be like this. The list will be like this. So all the nodes will be linked to each other in a sequential linear manner. Okay, only one direction is possible. So here you'll be having sequential linear manner. Nodes are linked in this manner. Secondly, only movement can be done in forward direction. Movement in forward direction only. Okay, so if suppose you are here and you want to access the previous node, you cannot access from here. Okay, because in linked list, in a single linked list, we can move only in the forward direction. From here you can reach here, from here you can reach here, but opposite traversing is not possible in this case. The second linked list is doubly linked list. In case of doubly linked list, we use 2 pointers, like each node will be having 3 fields. The middle one will be data field. This node will be this particular field must be storing the address of the previous node, and this one will be storing address of the next node. Similarly, the next node and So here we can move this will be null only because this is the first node. So you can see that here every node is previous, data and next field. So here you can see that from this node, if you want to traverse first node, you can traverse because this node is storing the address of previous node also. This previous and next both are pointers. So this particular node is storing the address of the previous node as well as the next node. Now this one is the last node, that's why here it will store the address of the previous node, but as this one is the last node, that's why in the next field you will store null. Similarly for the first node also, because this is the first node, there is no previous node for this. That's why we have stored null in the previous pointer. Okay, and in the next field it will store the address of this particular node. So in doubly linked list, here we use 2 pointers. Okay, you have to use 2 pointers, one for the previous node and second one for the next node. Then the second thing is that in doubly linked list, the current node, from the current node, suppose this is the current node, from here you can access the previous node as well as the next node. So 2 nodes you can access. So here the movement can be done in forward as well as backward direction, both the direction. From a particular node, from our current node, you can access the previous node as well as the next node. So we can access 2 nodes. Then the second thing is third type of linked list is circular linked list. Circular linked list. So in case of circular linked list, we are having nodes. The only difference between this one and single linked list is that in the single linked list, the last node contains null value in the last node next field, but here the last, suppose there are only 3 nodes in the list, so the last node is going to contain the address of the first node in the address field or in the next field. In the next field of the last node, the address of the first node will be stored. Okay, so here you can traverse in the forward direction, but after last node you can access the first one. So that is the only difference. Okay, so that you need to remember that these are the 3 types of linked list: single, doubly and circular linked list. So in the single linked list, only forward direction is possible. In doubly linked list, both the directions, forward as well as backward, is possible. In circular, we can access elements in forward direction only, and from the last node you can access the first node. So you can see here that there is a link. The last node is not containing null in the next field, it is containing the address of the first node. So after last node you can access the first node. So I hope all these things must be clear. There is one more thing in linked list that I want to discuss, that is the concept of head. Now, as in case of array, you are having the concept of index. If you want to access any particular element, you can access it through index. Here in linked list, how we are going to traverse or how we are going to access any particular element, that will be through head. Head basically we use in order to access any particular node. Like, let's say we'll take the example of single linked list. Now here, if I want to access any node in the linked list, I need to start from the beginning. Okay, now in case of array, we discussed about the base address. If you want to access any particular node in array or any particular element in an array, then in that case, if you know the base address, you can access any element in that array. Similarly, here also this concept of head node is used. Like the address of the head node is stored in a pointer variable head. So what we are going to do, like here we have taken n is the alternative name for struct node. So what we are going to take, we are going to take one pointer variable head which is going to store the address of the first node. So always it will be like this. Head will be a pointer which will be pointing to the first node. So in case if you want to traverse any linked list, or in case you want to access any node, suppose you want to access this node, then you have to traverse it from here. Okay, from here, then from you'll reach here and you can print the value of this node. Okay, so we are going to take head, and this, you remember that this we need to declare in a global space. Okay, we'll initialize it to null. As we are initializing it to null, that means that initially our linked list is empty and there is no node in the linked list. So when we'll insert any node in our linked list, if it is the first node, then that will become the head. Okay, this pointer head will point to that node which you'll insert for the first time. So I hope all these concepts must be clear about the introduction of linked list. In the next video we are going to discuss about insertion in single linked list, and there are 3 types in which you can insert in a linked list, single linked list, that we'll discuss in the next video. In case you have any doubt, you can share it in comment section. Thank you so much.